In this video, we're going to finish topic 3.4 with example 2D. And hopefully you've noticed that all the rules that we've had before for derivatives apply. So we're seeing a lot of chain rule in these. We could also apply product rule, so you could see a lot of different things happening in the homework, even if we didn't do the example here in the notes. So I'm starting by noticing in this one that my outermost function is the squared, so that piece there is going to be my first u. So u equals secant to the inverse of e to the 2x. And then when I go to start taking that derivative, I notice, ooh, there is another u in there. So I'm not going to call it u, I'm going to call it w. So, and then I've got e to the 2x. And then I notice in there, there's another one. So it just kind of keeps chaining. So this one's kind of a little bit insane. So I'm going to call that v. But that's okay, it's good to see a hard one. So so my v is 2x. So v prime would be 2. So now I'm going to go backwards through the chain. That means that w prime equals e to the u. Sorry, w equals e to the u. Now w prime would be e to the u times the derivative of the outside, which was 2. And then I'm going to multiply that, then I'm going to replace my u. So it'd be 2e to the 2x. I'm going to go backwards in the chain again. So my original chain is secant, I'm just going to rewrite it as secant inverse of u. So not of u, of w, because that's what we turned it into, of w. All right, so I'm going to go to my formula now and take the derivative of that. So if I look at my formula for secant, which we hadn't done one yet, it's 1 over the absolute value of x, square root of x squared minus 1. So 1 over the absolute value of u, square root of u squared, plus, or minus 1. And then we multiply that by the derivative of the inside, which was the 2e to the 2x. I'm going to replace that with the u, so u prime equals 1 over the absolute value of my u, or my w, sorry, I should have used w, not u. So these should have been w's. So my w was e to the 2x. So I'm going to replace that with the w, square root of e to the 2x squared, and then minus 1. And then I also have to make sure I multiply by this 2e to the 2x. I'm going to go spend one line simplifying this, and then we have to go back and do the final piece of the chain. So 2e to the 2x. Actually, there's something, well, I'm going to do a couple lines of simplifying here. The absolute value of that is just going to be e to the 2x. And then this squared would be the square root of e to the 4x minus 1. And then hopefully you're noticing that these cancel. So I really have that u prime is 2 over the square root of e to the 4x minus 1. I think that's the longest chain we have done ever. Now I'm not done yet, because remember, this was just derivative of the inside function. I still need to go back to my original up here and replace. So I'm going to use their derivative notation. So we have to find, actually I'm going to use the y equals notation. It's just easier. So y equals secant inverse of e to the 2x. We're going to square that whole thing. I'm going to replace this piece here with u, so u squared. So take the derivative. I take the derivative of the outside function, which would be 2u. I'm going to multiply that by the derivative of the inside, which was the mess that we found, which was 2 over the square root of e to the 4x minus 1. And now we need to replace the u. So y prime equals the original u we had, which is way back up here. So secant inverse, so 2 secant inverse of e to the 2x. Yeah, of e to the 2x. Or sorry, e to the 2x. And then we're going to multiply that by 2 over the square root of e to the 4x minus 1. The only thing else I could do is I could multiply this 2 with this 2 and make it one single fraction. So let's go 4 secant inverse of e to the 2x over the square root of e to the 4x minus 1.